Hello, everyone. Welcome to Dev Days Europe. This is our third session for today. I'm Christina Colliver, your host, and we're starting with no excuses anymore. The demise of cross-site scripting with our guest Christian Wenz. He's
Hi.
a CEO, a book author. Hi, welcome. Thank you for being with us. Christian is the co-author and author of 100 computer books. I was utterly impressed.
Thank you, but it's just a hobby. I do have a day job, so
If you're just if that's just a hobby. Christian, why do we still fail to defend our web applications from cross-site scripting?
I have some theories, but I thought today I'll rather focus on making applications more secure, and will try to provide some extra layers of security that can help us if our existing security measures, hopefully we have some of them, will fail. So that's the idea of today. So in my day job, I really try to make web applications more secure. Um, I work on a lot of projects and work with development teams either before or after an audit. And sometimes I do the audit. So I am talking about cross-site scripting and that there are no excuses that you have, well, either cross-site scripting or at least exploitable cross-site scripting. I mean, I've been thinking about that for decades, literally now, that eventually cross-site scripting needs to die. Um, but I was looking at cvedetails.com the other day, and it doesn't really look like that. So that chart basically shows that the number of CVEs that is reported uh, with regards to cross-site scripting each year. It's a bit hard to see depending on your screen. So the x-axis goes from 1999 to 2023, and the y-axis is the number of vulnerabilities reported. Cross-site scripting vulnerabilities, that is. And you see, we are at 2023, we are at about, let's say, 60% of the 2022 values, but we haven't even passed the half year or mid-year barrier yet, right? So 2023 will once again be a record year with regards to cross-site scripting. And usually a record year is a great thing, but here it's an extremely sad thing. So I would like to briefly discuss why there is still cross-site scripting, and then talk about countermeasures, direct countermeasures, and maybe indirect countermeasures that don't prevent cross-site scripting vulnerabilities to be in existence, but make it hard to impossible to exploit them. And at the end, your applications should hopefully be completely free of cross-site scripting. So here we go. Cross-site scripting, I mean, is a rather unfortunate term because we are not doing any scripting. And I mean, what does the cross-site mean here? The term was coined actually 25 years ago by the Internet Explorer team. But I mean, actually, what happens is that we are injecting something, usually in an HTTP response or in the HTML context of a page in the browser. Most of the time, it's JavaScript code, but it could also be HTML or other content. So JavaScript and HTML injection would have been a better name if you ask me. But anyway, I digress. So we inject JavaScript code into the HTTP response into some HTML. And that code then runs in the security context of the page. That's due to something called same origin policy, which we will have a look at in a minute. But just remember, if there is some JavaScript code in your application that does not belong there, the JavaScript code is allowed to do the same things your application code does. And that could include stealing cookies, depending on how cookies are configured, redirecting the user to some other sites so that could turn into phishing eventually, and manipulating the DOM. So adding elements to the page, removing elements for the page, etc. So lots of great options. But in theory, defending against cross-site scripting should be trivial. When we have an HTML context, there are 5 special characters: the opening and closing angle brackets for delimiting tags and elements, the double and single quotes for delimiting attribute values, and the ampersand character, because the ampersand character denotes or starts entities. And all major web frameworks have built in safeguards or helper functions or helper methods that at least try to replace those 5 characters with their associated HTML entities. I just picked the two most popular web frameworks at the moment from a market share perspective. So PHP has the HTML special class method, and they have it since I think 1997, right? And ASP.NET Core, there is the HTML encode method that dates back to basically classic ASP active server pages, so also 1996, 1997. So the remedy has always been there. But supposedly people didn't use it enough. Just remember the diagram we had a look at. Also, when using ASP.NET Core, when you output a value there using the add character, HTML encoding takes place as well. So actually, whatever data you output, you should be safe. Still, there's lots of cross-site scripting, and there can be several reasons. For instance, these measures only work if you're in an HTML context. If there's a JavaScript block on your page, and in the JavaScript block you are kind of outputting user-supplied data, then there are other special characters. So that is something that you may overlook. Or if you're working on a single page application, then you have JavaScript code that then takes data and applies it to the page or puts it into the DOM. And then you kind of circumvent the server, and therefore you also circumvent those escaping methods. And just briefly, I would like to stress why cross-site scripting is such a problem, because when we are demonstrating cross-site scripting, usually, especially when performing an audit, the job is to prove that there is cross-site scripting. So all you get is some way to inject trivial code like alert 1. Okay, no one is afraid of alert 1, right? But yeah, if there is a real exploit and someone maliciously tries to attack your site, well, and succeeds, then it won't be alert 1. It won't be something worse. And just to hammer this point home, JavaScript, I think you've all heard the story, right? JavaScript was cobbled together in mere 10 days. So 10 days for specifying the language and implementing it. An amazing feat. And actually, there has still been time for a security concept or a security mechanism. And that one's called same origin policy. Don't get fooled by the term origin. It doesn't mean origin as in the English term origin. It means origin as defined by the IETF, the Internet Engineering Task Force. They once defined the origin of any URL is a fixed term, and it's the scheme or protocol, the fully qualified domain name, and if it's not the default one, the port. So that URL here, http example.com port 81/page, has the origin as defined by the IETF of http example.com port 81. Let's assume this page uses JavaScript 3 times. There's some inline JavaScript, top left. There's some JavaScript file on our own server, top right. And then we also pull some JavaScript code from a CDN, so from a third-party site. And the same origin policy says that JavaScript has access to things, quote unquote, that have the same origin as the the code itself. And remember, origin is protocol plus domain plus port. So what is the origin of the inline JavaScript code top left? That's obvious, right? http example.com port 81. What is the origin of the script.js file top right? Again, easy. http example.com port 81. And what's the origin of the library we pulled from a CDN, lower right? And the intuitive answer would be, yeah, obvious, https code.jquery.com. But if that was the case, the library, in that case, jQuery, but it doesn't really matter what kind of library it is. The library, if the origin was https code jQuery.com, thanks to the same origin policy, would only be allowed to uh, work on content and talk to the DOM on https code jQuery.com. But I don't know if you've ever included an external library from some CDN, but you will have noticed that it still works. So the origin, as in same origin policy of here the jQuery JavaScript file, is also http example.com port 81. So the origin of JavaScript code is always the origin of the HTML page that either loads or contains JavaScript code. Right? So everything a page loads runs in the origin in the security context of that page. That absolutely makes sense. But what does that mean if we have cross-site scripting? Then we have some extra code that also runs in that security context of the current page. It's like having a new team member in your development team, but that team member can bypass code audits, right? So that team member just checks code in and tells no one. That's what cross-site scripting is. And since this is such a big problem, browsers started to implement security measures against cross-site scripting, and Internet Explorer 11, I believe, was the first browser to include a cross-site scripting filter. So they were just implementing some heuristics, things like, okay, there is a script tag in the URL, and the same script tag is also on the page. It could have been that could be cross-site scripting. Let's just block it. But in order to still give the impression that IEA was a fast and high quality browser, and in hindsight, I mean, well, maybe there were other browsers that were superior. But anyway, so in order to maintain that vision, the cross-site scripting filter had to be fast, because if it's slow, people won't say, "Oh, thank you that we have a secure browser," but rather, "No, thank you not for being a slow browser." Also, the filter should not have any false positives, so should not identify something as cross-site scripting which wasn't. So essentially, the filter wasn't good. The other major browsers, except for Firefox, said, well, but still, the idea is laudable, so we implement something in our products as well. Only Firefox said a filter that's fast and not good is not something we should rely on. Turns out the Firefox team was right. So in the end, the feature has been removed. So the only browser left with that feature is IE, but IE ain't anymore. So you see here that pop-up that appeared when Internet Explorer thought there was cross-site scripting. But yeah, the idea was good, but the it wasn't a good implementation. And of course, since then, the web security community thought about different approaches, and they did find one. And I would like to spend some time in showing you that, because I think this is a game changer when it comes to cross-site scripting. That's called content security policy. Now, before we proceed, one important aspect. Content security policy is a so-called defense in depth mechanism. It makes exploiting cross-site scripting vulnerabilities harder. So it's a great additional firewall, so to speak, for your web application. But of course, it's no excuse to not think about cross-site scripting in your applications at all, right? You have to avoid having any cross-site scripting vulnerabilities. Content security policy is just is on your back in cases that you fail with that, right? But of course, the application should be vulnerability free anyway. There are 3 versions of content security policy at the moment. Version 1 was almost a W3C recommendation, but was then demoted to a working node because version 2 was turned into a W3C standard, a W3C recommendation about 6.5 years ago. So quite a while. And is supported by all major browsers. There's also a version 3 that's actively being worked on. So the last update to that was earlier this month, actually. The only issue is version 3 is driven by people from Google. That, of course, isn't a problem. But what they're doing is that Chrome and Chrome-based browsers like Edge and Opera, they are already implementing parts of that version 3, whereas the other browsers, most notably Firefox and Safari, they basically wait until the specification is done, because there could still be changes, right? So the old backwards compatibility issue. And we'll focus on version 2 today as well. And you can do a lot of things with version 2. And by all means, apply it. What I'm about to show you is now how content security policy works, just as an overview, and what happens if you apply it to a bad application. Why am I saying a bad application? If you have a great application and you start by having a content security policy from day one while working on it, that's absolutely awesome. But of course, you will have legacy applications, and you would like to give them an extra layer of protection as well. Depending on the quality of your legacy application, there might be some issues. So I'd like to show you the issues and remedies so that at the end, you will not only be able to apply content security policy for future projects, but also consider using them for existing ones. Content security policy works by setting an HTTP header. You could also use a meta tag, but all features are only available if you use an HTTP header called content-security-policy. And the value of that HTTP header consists of an arbitrary number of so-called directives. Directives are the things with the dashes here, default dash src, image dash src. And a content security policy essentially tells the browser where to load resources from. And even if you have never seen content security policy before, I think you will be able to decipher what happens here. So there is a default directive which applies to any kind of content. And it basically says here, load everything from self. Self in single quotes, that's a constant and means the current origin. So the current page may load anything from the current server, basically. However, you can override this default setting for specific types of resources. So for images, for instance, we say, okay, images can be loaded from self, but also from https static.example.com. I have a simple application running here. So basically, it shows the conference logo in a beautiful light blue background color. So probably someone from the design team is fainting right now because that's not how it's supposed to be, but it will become important in a minute. And it also displays the current time. How did I create that? So basically, what I'm having is I have some HTML. So this is using ASP.NET Core, but it doesn't really matter what technology is being used. And here I say, okay, I would like to have an image with a light blue background, and it should have a third of the page's width. And since I'm stingy, I'm stealing that image from the conference website, right? So that they have to pay for hosting, not I. Um, so I'm loading that image, and then I have a placeholder here with extra large font, makes it easier to see during the presentation with the current time. Then I'm loading the underscore JavaScript library. It's a templating library, and I'm loading it from a CDN. And then I run code. I run code every 1000 milliseconds, so once a second, and that code updates the time and uses the current locale time. Now, what does this update time function do? It's defined here in that file. So we start by using the underscore library, thus the underscore, and we set up a template. And the template looks like this: current time, colon, and then a placeholder for the time. And in the update time method, we take the template and we basically run the template, providing the time that was submitted as an argument. And in the end, we put this in our placeholder. So essentially, once a second, the JavaScript code determines the current time, uses the templating engine, and updates the output. So you see here the current time where I'm at is a quarter past noon at the moment, right? So you know which time zone I'm in today. All right. I mean, let's just add a content security policy. So I've already prepared that. We set the content security policy header, and we could just do something like this: default src self, because that would then just set a very simple content security policy. What could go wrong? What could go wrong? And so we are reloading, and okay, site can't be reached because it's still compiling. There we go. Yeah, so the current time is much smaller than before. Yeah, the time is also missing, but that's just details. And the image is gone. Okay. I have a hunch what the reason is, because remember, I'm stealing the image, right? Um, So I have to basically say, well, images, they can come from self, like the fav icon, but they can also come from here. I can use an origin like this. I could also use a full URL. And in general, it's best to be as specific as possible. So don't greenlight the full server. You don't even know what's on it. Just greenlight the specific files you'd like to use, or maybe just the full uploads folder or whatever. All right, once that change has been implemented, the logo is back. but the size I think is a bit different and the blue color is missing. So still some work to do on that application. Let's proceed. Maybe we can find out what's the problem here. Um, there are several directives when loading resources, and I mean I won't go through all of them, but I think from the names you can directly deduce what they're good for. So for instance, font src will cover loading of web fonts. Media src will be for audio and video. Style src will be for loading style sheets, and script src will be there for loading javascript code. And now it's getting interesting. I mean, we're here for cross-site scripting. Oh, well, we are here against cross-site scripting. If we set the script src directive or default src, which applies to everything, if we set that to say self, then the only JavaScript code we can include is code from our server. And I mean, there won't be any malicious JavaScript code on our server, right? If there was, we would have other problems than cross-site scripting, right? So even if we have a cross-site scripting vulnerability, someone cannot inject script src equals attackerserver.com/malicious script.js because that's not on the allow list in our content security policy. But why is the application not working? Well, let's maybe have a quick look at available values for our directives. We can greenlight everything, so that's the star or asterisk. We can use an origin or a URI, and there are some constants. Self, we've already seen that, and none. So for instance, good news, if you use the policy script-src none, then you won't have any exploitable cross-site scripting. You also won't have any running JavaScript code on your page, even your own, so maybe that's not always the best option. But still, it would be possible. But still, we have an application that is not properly running. So what doesn't work? The blue color ain't there, the size is incorrect, and also the font size doesn't work. What do those three things have in common? They're inline styles. If we have a content security policy that applies to style sheets, like default src, image src, then inline styles are deactivated, disabled. Okay. We can live with that. But of course, if we have a content security policy that covers JavaScript code, like script src or default src, inline JavaScript code is deactivated. Uh, uh, okay, that's a bit unfortunate, especially for legacy applications. But I mean, it makes sense because inline JavaScript code is the other cross-site scripting vector in injecting script alert one. So it's enabled. Of course, I mean, I could go to my application and then just externalize this JavaScript code, right? I mean, I already have a JavaScript file where I could put this to, but still it wouldn't work then because there is another side effect, so to speak, intentional side effect of a content security policy. Eval won't work. So the eval function in JavaScript, which makes sense, right? Because it takes a string and then runs it as code. And everything that is comparable to evil. One of those things comparable to evil is using a string for a set interval call. All right, fine. I mean, I can convert this into an anonymous function. But I'm using underscore here, right? And I mean, I'm not ranting against the underscore library, not at all, but it's a good example here. Underscore JS is also using eval internally. They're using new function to be precise. I mean, would I like to enable inline JavaScript? No, not at all. If I enable inline JavaScript, then cross-site scripting can be exploited. Would I consider enabling eval just for the sake of making underscore happy? Well, in our case, since the only value users applied, or the codes applied value I'm putting in the templates current time, maybe I could. Well, so we can re-enable inline, but we have to feel the pain while typing. So it's not called something like enable inline, it's called unsafe inline because it is unsafe what we are doing here. Consider doing that for style sheets, but absolutely do not do that for JavaScript. And we'll solve that for JavaScript in a minute. If we are re-enabling eval, the constant to use is unsafe-eval. Okay. So again, we have to type unsafe. So we have to know what we are doing. We have to be aware that this might be a security related problem depending on what our code does. But if you know what we are doing, then maybe it's acceptable to use that. So let me quickly fix that, just to show you how that could be done. So for style sheets, we are using self again, of course, and unsafe dash inline. And for JavaScript, well, we are allowing self, we are allowing unsafe dash eval. We should also allow the server from which we are loading underscore JS. And I'm using the complete URL here because I don't want to greenlight the full CDN. There might be some old JavaScript code in it with security vulnerabilities. So this is part of the solution. So if we reload the page, to find out font size is back and the light color is back, the right size is back, but the time is still missing because we still have inline code. I could externalize this, but I would like to briefly show you how you can re-enable inline code. There are two options. You can use a one-time token. So the idea is in your content security policy, you add a constant nonce, that's for number used once, dash, and then the random token. It should be more random than this, of course. And then in the script tag, you use the nonce attribute, and the nonce attribute is set to that random token. So that token has to be random with each request so that an attacker cannot predict it, but that would work. So actually, let's try this real quick. So for the script tag, I'll just add a nonce, and I use something simple, ABC123. And then in the HTML, I use nonce equals ABC123 here. So it should be the same value, right? And this allows all the script elements that know that secret token, that nonce ABC 123. And now the time is back. So the application is working again, right? You see, it took me a few steps, but just because I crafted the application the way it is, so that there are issues involved. You could, instead of just greenlighting everything with the right nonce attribute, you can greenlight specific JavaScript code. The idea here is if you have a script tag with inline code, you can calculate the SHA-256, 384, or 512 hash of that, and also put it in a content security policy like this. So that specific code is allowed to run, but if an attacker injects their own code, that code will have a different SHA hash, and therefore it will not be run. So you can really greatly configure that. And one more thing about content security policies, there's a directive called report URI that's used for reporting. So the idea is you provide a URL here, and whenever there's a policy violation, the browser automatically sends an HTTP post request with information about that violation, which page, which line, which policy, which directive was violated, etc. So it's basically a JSON block that is sent to the endpoint. So you just implement the endpoint, or there are also commercial services, but always consider, do you really want to have security related information residing in a third party? So you have to do the risk management here. But basically implement the endpoint, and then you will always get informed when there's a policy violation. And there are only two reasons for a policy violation. One is you messed up in your policy. There is this tracking pixel loaded from some third party server. That server is not part of the policy yet, so you have to fix your policy. The second reason is you have a cross-site scripting vulnerability and someone is actively exploiting it. You want to be informed either way, right? So use that feature anyway, but it's getting better. There's a second HTTP header, content-security-policy-report-only. Same syntax as content security policy, but the policy is not enforced. So you take the same policy, the browser parses the policy, looks for violations. For each violation, there is an HTTP post request being sent to that endpoint, but the policy is not enforced. Your application continues to work as before. That's a great way to apply a content security policy to a legacy application. Create and test the policy and then put it on the production system with content security policy report only, and see whether there are any reports coming in. If they do, fix your application or fix the policy. And if there are no reports coming in, then the content security policy seems to be compatible with your app, or vice versa, and you can move to content security policy. So please, by all means, implement that in your applications. So that gives us an additional firewall against cross-site scripting. But there's one more topic I'd like to cover, and that's single-page applications. Because in single-page applications, sometimes the server is not needed, and a lot of stuff happens on the client. So what can we do there? Because most of the time, the cross-site scripting vulnerability there is whenever we write something to inner HTML. If you're using a SPA framework, sometimes there are security safeguards included. So for Angular, for instance, Angular trusts no one except for templates. So if you have JavaScript code in your templates, then the JavaScript code runs. That's kind of the idea of templates. But if you're using the double curly braces syntax, like shown here on the slide, hash hash curly curly property, then that gets automatically HTML encoded. So even if you have no clue what you're doing, you have some level of cross-site scripting protection there. There is one notable exception though. When you bind directly to the inner HTML DOM property, like shown here in the square brackets, that there's no encoding going on here, right? Because you're binding to a DOM property, and if you're doing that, especially to inner HTML, you most certainly want some HTML to be put there. But of course, that HTML could also contain a script tag. So audit your code for those instances where you do something like this, and then check whether that property that you are binding to the inner HTML property is sane or is users applied. And if it's users applied, congratulations, you may have found cross-site scripting. There's also a DOM sanitizer being used, which tries to remove dynamic content from HTML. And always, when you have URLs, always be aware that there is something like href equals JavaScript colon and then some code. Angular tries to filter that out, but it can't when using iframe URLs. Other SPA frameworks do a similar thing. So for instance, React also auto-encodes. So there the syntax is just one curly brace, but they don't do that when doing URLs. So be super careful when linking to URLs that are user supplied because they could start with JavaScript colon. And what I really like, I mean, this unsafe inline we had in cross-site scripting was kind of nice, if you ask me, because it made you aware that what you're doing is unsafe. It's even better in React. So if you want to bind values but would like to skip the HTML encoding, you have to set an attribute that is really called dangerously set inner HTML. So you really have to type dangerously. So even if you have never heard of cross-site scripting before, then still you kind of have a hunch that something fishy is going on here now, right? So I really like that API. Also, what the React team recommends actually is to use a tool called DOM Purify. That's an open source project that basically takes a string and tries to remove everything dangerous from it, which is pretty hard, but they do it really, really well. They do it in a shadow DOM, so they really use the browser for parsing, and then in the end, you should get something safe. Again, open source project, really, really fast. Has some other nice additional features, and eventually it will get replaced by something else. Even the maintainers of the project wish that, so they are contributing to that effort. So there will be the HTML Sanitizer API. Well, the HTML Sanitizer API already exists, but it is still being worked on. So the idea is that you clean HTML by removing certain tags and removing almost all attributes, because as you know, attributes like on click, on something can be used to run JavaScript code. Some of this has already been implemented. So if we go to canIuse.com and look for the sanitizer, not sanitizer, sanitizer API, you see, okay, it's there in Chrome and in Edge, but not in Safari yet, but in Firefox, and maybe hard to see, maybe I should zoom in. There's a note, you can enable it with a configuration setting. So Firefox is already experimenting with it, but doesn't give full support out of the box. So that's why you need DOM Purify at the moment. Also, the API supported by Chrome and by Firefox are different ones. So the features supported are different ones. And there is one more thing, and that's the last thing I would like to talk about today. And that's called trusted types, or the trusted types API. As I mentioned, big cross-site scripting vector is assigning strings to inner HTML. And two related properties. But basically, that's what we have. Now there is the trusted types API. The browser support is not as good as the sanitizer API yet, but it will get better because there's commitment by other browsers to implement it. So as of now, only Chrome-based browsers have it. So Chrome, Edge, and Opera, and of course the mobile ones. But eventually, Safari and Firefox will follow along, and that's specifically, and you can read it here, against cross-site scripting attacks. So what the idea is that we once again use a content security policy, and this time we are using a new directive, required dash trusted dash types for, and then script, which basically says in JavaScript, when setting something to inner HTML, we can't use any strings. The only thing we can use is a trusted string. And actually, let's have a look at that in code. So here's a simple application. I have a text field here, and I can enter something into the text field. And then it will be written into inner HTML. Let's have a look at the code, or at parts of that code. So that's what happens when I click on the button. I read out the value from that input field. Then I write it into the inner text property of a placeholder so that we see anything. And then I try to write it into the inner HTML property of another placeholder. Now, the way how browsers work, if that was written in inner HTML now, JavaScript code would not run. So I would rather need to use something like an HTML element and then an on something event handler. But I can still show you what the effect is. So I open up the console, and then I hit that inner HTML button, and you see that we now get an error. Failed to set the inner HTML property on elements. This document requires trusted HTML assignment, right? So I see the text output, but not the HTML output. And then there's another button. And to show you that, I start here with 1, 2, 3, and here with 4, 5, 6, and hit that button. And now you see that the script element is removed, and only the thing before and the thing after it remains. How was that done? Let's have a look at the code. I told you about DOM Purify. Before outputting the data from the user, I sanitize it with DOM Purify, and I configure DOM Purify to return not a string, but a trusted string. And that's why I can set it to inner HTML. So there is no error now in the console because I get a trusted string, not a simple string. And using a pattern like that can greatly help defeat cross-site scripting, especially in single-page applications. So don't write anything to inner HTML. Use that content security policy, and I'm using a meta tag to set it. So use the content security policy of require trusted types for script. And then you can't set inner HTML to any strings. So you have to have a trusted string, and a great way to get a trusted string is to use something like DOM Purify. And so that should greatly add an extra layer of security to your JavaScript-based applications. And that's all I wanted to show you. So cross-site scripting is still a big problem. With content security, we have a great additional safeguard against the attack. And remember, it's an additional safeguard. No excuse not to have any cross-site scripting protection in the app. Single-page application frameworks already come with some cross-site scripting protection out of the box. And with the Sanitizer API, and especially with the Trusted Types API, we will have even more weapons against cross-site scripting in our arsenal. And as it said on the first slide, and as I will also say here now at the end of this talk, there is no excuse for cross-site scripting anymore, because now they are really effective and great safeguards. And with that, good luck in thanks for attending. Hope you have a great conference. I'm there for any questions, and hope to see you soon at the next exhibition, maybe even in person. That's actually what I'm aiming for. And with that,
thank you, Christian, so much. That was very useful. Absolutely, I think most of us are contemplating and thinking about where I'm using inner HTML and
that
where
is
I'm.
the plan. That is the plan.
I am certainly. There are no questions for the audience. I think they need to see that in. That's
yeah.
There's
Try that out. If you have any questions, you see my contact data here, so easily reachable on Twitter or just send me an email. And
I have a usual question.
Sure.
Do you remember any recent exploit of cross-site scripting that you had to investigate?
Yes, I do, but obviously I can't mention that. But let me just say, it was indeed an application that had lots of. Well, actually, there are two things that come to my mind. One is an application that had really good, so the default cross-site scripting safeguards. So they were using a stack that protected them, but they had this one JavaScript code where user-supplied data was put into the JavaScript code and HTML encoded. But in JavaScript, we have other special characters, so I could exploit that. And the other one, of course, is a classic. So you saw me the setting up the content security policy so that we can load the external JavaScript file from the CDN. And you may have noted that I put in the complete path to that file. So if the library version is updated, I have to update the content security policy as well, which sounds like extra work. But I had one case where the whole CDN was put into the content security policy, and that CDN also had, of course, other libraries, including ones with security vulnerabilities. And then there was actually a cross-site scripting vulnerability in the app, and we could exploit that by referencing that insecure JavaScript file from the CDN. So better be strict and explicit.
Yeah. No. Use content security policies and mind the exceptions.
Make it as strict as possible.
Yeah, make it as strict as possible and mind the exceptions. Don't just unsafe things and don't just do dangerous things.
Exactly.
Because if there is a bug and if there's a vulnerability, somebody will exploit it. That's the law. Thank you so much. Follow Christian and have a great day ahead. See you after the break.
You all as well. Thank you very much. Thank you.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and I am illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's stars. We don't need